Okay, so we come to complex numbers now. And, well, what are they, firstly? Okay, the very starting point is this right here, the square root of -1. Okay, you may have gone through all the school saying, teachers just saying, you can't do the square root of a negative. Um, and, well, you cannot do the square root of a negative and get a real number, okay, i.e. any other numbers you're familiar with. Okay, but mathematicians need to be able to describe what happens still. Okay, they're not really content with just saying you can't do it. So we give this a value. We give this an I. Okay, that is, well, it's still not a real number, and in that sense, we call it an imaginary number, hence I. Okay, so this is a number, but just not in the regular number system that we're used to. Okay, this is I, and well, we could do the square root of -9. Well, that would be the square root of -1 times the square root of 9. So this would be 3I. Okay, so how do we work with these? How do we manipulate these? So that's what we're going to go through now. What about combining real numbers and imaginary numbers? So what would be 2 plus 3I? Would it be 5i, 5, anything like that? Well, no. You can think of this as like what's 2 apples plus 3 oranges? Well, it's just 2 apples and 3 oranges. It's not, you can't combine them. Okay, kind of like when you're combining like terms in algebra as well. Okay, so, well, no, we can't do anything to this. This is just simply 2 plus 3i. Okay, but this brings us on to sort of what we now think of as a complex number. Okay, a complex number can be a combination of real numbers and imaginary numbers. Okay, so we usually give the letter Z to a complex number, and it has a real part. Okay, 2 is a real number, and an imaginary part. Okay, 3i. And you can also see this notation here, the RE for real, so the real part of Z would be 2. The imaginary part, I guess I shouldn't underline that all, the imaginary part is 3. Okay, and meaning that Z was 2 plus 3i. Okay, now quickly, how do we add, subtract, multiply, and divide complex numbers? Well, you can think of this almost exactly as if I was just your variable, okay? As if this was 4 plus 5x plus 7 minus 2x. Okay, you would just combine the x's, you combine the numbers, and you do the same here. You combine the real parts, okay, 4 plus 7, and you combine the imaginary parts as so, and you just combine them. And you get your new new complex number. Okay, subtraction, as you can imagine, almost exactly the same. Just do -3 minus 6, that is -9. And then I minus 8i is -7i. And we have our new complex number. Okay, so that was really just very familiar, regular algebraic manipulation. This is where it's a little bit trickier. Okay, what we've got to remember here is that the square root of -1 is I. Okay, and if I squared both sides, well, if I squared the left-hand side, this would become -1. Okay, and well, then I have I squared is -1, which makes sense. The square root of -1 is I. That means that I squared is -1. And that's going to be very important here. Okay, we start off with again, just regular algebraic techniques here. Okay, regular expansion, distributive property. Okay, we have 28. We have plus 35i minus 8i. But here we get 10i squared. So, well, firstly, I can combine these middle two terms. But then I squared, we just said I squared is minus 1. So minus 10I squared is minus 10 times minus 1. And that is that gets simplified to plus 10. And so now it's a real number, essentially. And I can combine it with the 28. I get 38 plus 27i. Okay. And division, probably harder still. There's a couple of ways of doing this. There's one way where you can just assume that this is going to be a complex number. A plus bi is commonly used. And you can go from there and multiply by this denominator. Okay, expand this, and then set the real parts and imaginary parts equal to each other. That's a perfectly valid way of doing this. But I'm going to show you another one. Now I'm going to multiply this by another fraction. And it's going to be not 4 plus i, but 4 minus i. This is what we call the complex conjugate. Okay, where you just change the sign of sorry, not numbers. Where you just change the sign of the imaginary part. Okay, so 4 plus i becomes 4 minus i. 2 minus 3i, the complex conjugate would be 2 plus 3i. Okay, so you multiply by the complex conjugate over the complex conjugate. Now, what happens when you do that? Well, I've got to do this multiplication thing twice now. That's 24 plus 8i minus 6i minus 2i squared, hence 2 just plus 2. But what happens with the denominator here? I've got 16 plus 4i minus 4i minus i squared, which is plus 1. And the most important thing here is that you'll see plus 4i minus 4i is 0i, or just 0. And now we suddenly have no imaginary numbers on the denominator, which is great. So 26 plus 2i, and that's just over 17. It's not a nice fraction, but I can just split this up into real part and imaginary part, and I have a nice, simple, complex number. Okay, and that is the division of 6 plus 2i divided by 4 plus I. Okay.